In this video, we will look at some of the fundamental mistakes students make for inequality problems. And the main mistake that students make for inequality is due to they apply blindly the algebraic rules that are meant for equality in inequality problems. So we are going to look at a few examples of what are some of the common mistakes students make and how we should rectify them. Let us first look at an example involving a power tool or a quadratic expression. So if I ask students to solve x squared equals to 5, I guess everyone, or at least most of the people, will be able to give me the answer as x is equals to positive or negative square root 5. So now let's change the question from an equality to an inequality. So now what if I ask them to solve x squared greater than 5? So what some students will do is they'll blindly apply what they learned for equality and use that as an inequality answer simply by changing the equal sign to the inequality symbol. So they'll just say x is greater than root 5 or x is greater than negative root 5. Now this is the wrong answer. And why is this answer wrong? Let's look at an example. So let's say if I have x is equals to 2. Well, x equals to 2 actually satisfies this condition because 2 is greater than negative root 5. But if we take power 2 of 2, it will give me a 4, which is less than 5. So what I'm trying to say here is that based on the wrong solution, well, x equals to 2 satisfies the solution here, but it doesn't satisfy the original inequality. So that means whatever solution students write over here is wrong. So how do we solve this inequality correctly? So I would like to propose we use the graphical approach rather than blindly memorizing some inequality rules whereby students don't really understand how do they work. So what we can do is we can simply sketch the x squared curve first. So it will be a U-shaped curve passing through the origin. And then we can insert the line y equals to 5. So the first thing what we can do is we can find the point of intersection. So finding the point of intersection means it's equality. So x squared equals to 5 means my x is positive or negative root 5. So what do we want is we want the portion of the red curve that is above the green line. X squared greater than 5 means the red curve is above the green line. So it will be the portion that I will shape in yellow. So what are the values of x in the yellow region? Well, we see that it's to the left side of negative root 5, also to the right side of positive root 5. So my answer will be x is smaller than negative root 5 or x is greater than positive root 5. Now the second example whereby students make mistakes often will be involving logarithm. So again, let us look at an example for equality. So if I have ln x equals to 5, so how to find x? All we need to do is to transform from logarithm from the left hand side to the exponential form on the right hand side. So in a way we say we bring the ln to the other side, so my x will be equals to e power 5. Now let us look at what happens if we have an inequality ln x less than 5. Again, a common mistake students make is they will blindly apply what they learn in equality and change it into an inequality form. So they will just say, oh, therefore x will be less than e power 5. Again, this is a mistake. Why is it a mistake? I will give you an example. Let's say where x is negative 2. Well, this is part of the solution written here because negative 2 is a value below e power 5. But you realize that this doesn't work for the original inequality simply because our logarithm is undefined when x is negative. So how can we solve this inequality correctly? Again, I'm going to propose the graphical approach. So what we need to do is to sketch out the graph of ln x, which looks something like this. So again, take note that the y-axis or x equals to 0 is actually the vertical asymptote of the logarithm graph. Then we will insert the line y equals to 5. And what do we want will be, we are going to find the values of x whereby the red curve is below the green line. So you can see the region I shaded in yellow is starting from the right side of 0 and to the left side of this intersection point, which you can easily solve as e power 5. So the correct solution to this inequality will be x must be greater than 0 and smaller than e power 5. Now the third example we are going to look at whereby students struggle with inequality will be involving the modulus. So let's say we have modulus of x below less than k. So this is the formula that students like to memorize, but they do not know that this formula has a condition attached to it. So what is the condition attached to it? This formula only works if my value of k is positive. So this is the part that students tend to forget, and they will wrongly apply the formula. So for example, if I have mod x less than -2, so what students will do is they will sort of open up the modulus, they will follow this formula. So they will just simply write it as x is between -2 to 2, which is obviously wrong. Why is it wrong? Because if I let x equals to -1, but if I apply the modulus, so x equals to -1 is part of this solution, but when I take modulus, it's actually +1, which is greater than -2. So I have an answer from this solution that doesn't satisfy the original inequality. In fact, this inequality does not have any solution, because when we take modulus, modulus of x has a value that is 0 or positive. So it will never be below -2. So one must be very careful when they memorize such formulas, and take note that the formula only works with the condition written in blue. So let us look at another example. So this time around we have a double inequality involving modulus. So if you want to do by the algebraic approach, the first thing we need to do is to split up the double inequality into two single inequality. So it must be modulus of x greater than -3 and modulus of x less than 5. Because it's a double inequality, so my job is to find the values of x that satisfy both inequality at the same time. That's why the word and. Now, for the inequality on the left-hand side, the solution is x can take on any real value. Like I said, because no matter what is the value of x I place in, if I apply the modulus, this will be 0 or positive, which is definitely larger than -3. The inequality on the right hand side, so you can apply the formula mentioned in the previous slide. So because this is positive, so you can apply the formula. So my x is between -5 and 5. But that's not all, because we still need to consider the a and d. So what does a and d represent? It means that I have to take the intersection of the two solution sets, and the final answer will be x is between -5 to 5. So you can see that if we want to do by the algebraic approach, it's actually like 1 step, 2 step, 3 step, 4 step, a 4-step procedure. So again, I'm going to propose another method to do it, which is by graphical method. So what we can do is simply sketch out the graph of modulus x, which is like a V-shaped graph. And what we need to do, it will be to insert the line y equals to 5 and y equals to -3. So you can find the intersection point first. So in this case, we have modulus x equals to 5. So x can take on positive 5 or negative 5. So I have 5 over here, sorry, negative 5 on the left side and 5 on the right hand side. So how do I interpret the inequality graphically? Essentially, what I want will be the portion of the red graph that is in between the two yellow lines. So it will be the region that I shade in green. So you can see that the red graph is in between the two yellow lines when it's on the right side of negative 5 to the left side of 5. So my answer will just simply be x is in between negative 5 to 5. Thank you for watching this Don't Do This video, whereby I share with you some of the common mistakes that you can easily avoid under the topic of inequalities. Do subscribe to my various channels, my Instagram, website, Facebook, or my YouTube video, as I share with you more and more useful videos to help you to get your desired A grade for your A levels. If you need additional coaching, you may contact me via this number. You can WhatsApp me or you can give me a call. Thank you for watching again. I will see you in the next video.